how would we write up the results in APA format? Well, here's an example of how these results would read. And I'm going to help you by, well, having them here obviously helps, but I'm going to show you that typically there are 5 components to writing up APA test results. And I'm going to give you the order they typically appear in. Okay? So let's just go over this and then we'll talk about the 5 components. So to test the hypothesis that this semester's grades are different from previous semesters, grades were analyzed using a two-tailed single sample t-test with a constant equal to 85. The results were not significant, and this is the statistical notation. You've been learning about that in the lab. This is new for you. This is Cohen's d, which is a lowercase d, and it's italicized. And because Cohen's d can be greater than 1, we put the 0 in front of the whatever the effect size was. All right, so it's 0.44. This semester's grades are probably equal to previous semester's grades. All right. Now, let's look at the different components, all right, or elements that we include in the write-up. So, number 1, state the hypothesis. It's up here. Test the hypothesis that this semester's grades are different from previous semesters. So there we have our hypothesis. It's non-directional because I'm just saying it's different. I'm not asking if it's lower or higher. I'm just saying it's going to be different. All right. So after you do that, state DV. DV, great. All right. Sometimes the DV can be more complicated and you have to give more explanation. But grades are grades. I don't think that's too difficult to understand. So we just said grades were analyzed. The third component is to name the test. So the grades were analyzed using a two-tailed single sample t-test. Right, so those are the specifics of the test along with the constant. Okay, so the constant equal to 85. Next, state results in APA format. So that's this here. All right, this one right here. And then number 5, state the conclusion in plain and simple English. So this last sentence needs to be phrased in such a way that people without any kind of, advanced statistical knowledge or even, the basic in statistics, they'd still be able to understand what you found. All right, so avoid jargon. So we just say this semester's grades are probably equal to previous semester's grades. All right, something grandma could understand. And I'm assuming most grandmothers are not statisticians. Now, I don't know if you noticed, but in the previous slide, we SPSS reported the test results using a two-tailed sig value. All right, said right there in the output, two-tailed sig value. So what would happen if we had run a one-tailed test? What would have changed? Would the t value be different if we ran a one-tailed test? The degrees of freedom or the sig value? Or would all 3 or 2 of the 3? The answer is just the sig value. All right, there is a formula for t's and they don't change depending on whether you did a one-tailed test or a two-tailed test. That does not change. Degrees of freedom don't change. They are what they are. But the sig value changes. Now, if we had run this, hypothetical experiment, and if we had done a one-tailed test, remember the sig value for the two-tailed test? It was 0.110. Now that's if, we split everything between two tails, right? We have 2 rejection zones. So what if we had just put all our eggs in one basket, have one rejection zone? Essentially, that is going to lower the sig value. All right, so instead of p equals 0.110, it's going to be less than that. Will it be enough to reach significance? Probably not, because this p-value will actually be halved. So what is half of 11? 0.11. That would be 0.055, right? I think. You know how I am with math in my head. If it's 0.055, that is not less than 0.05. So you still would not have significant results.